Calculate the magnitude of the normal force on a 12.7 kilogram block in the following circumstances. Enter your answers in Newton. Part A. The block is resting on a level surface. So if the block is resting on a level surface, the formula that we are using is going to be normal force equal mass of the block times gravitational force. B is saying the block is resting on a surface tilted up at a 30.8 degree angle with respect to the horizontal. So when the block is resting at an angle, the normal force, we're just saying that normal force minus mg times cosine of theta equals 0. It really means that normal force equals m times g times cosine of theta. Part C is saying the block is resting on the floor of an elevator that is accelerating upward at 4.78 meters per second squared. So when the block is on the surface of an elevator accelerating upward, it means a positive acceleration. It's positive 4.78 meters per second squared. So we can say that normal force minus mg equals m times acceleration in y direction and y-axis, which basically is the same as saying normal force equals may plus mg. Part D is saying the block is on a level surface and a force of 145 Newton is exerted on it at an angle of 30.8 degree above the horizontal. So in this case, normal force equals mg minus applied force times sine of theta. So we can just plug in the numbers and solve for the magnitude of the normal force in each case. So part A, we simply substitute m as 12.7 kilogram times the magnitude of the gravitational force, which is 9.8. The answer is 124 almost 124.5. For part B, normal force is going to be, so let me put 124.5 here. Okay, so for part B, the normal force is the mass of the block, which is 12. Okay, so I forgot to put the Newton here. Okay, so Newton. So 12.7 kilogram times the magnitude of the gravitational force, which is 9.8, times cosine of 30.8 degree. And the answer is going to be 107, almost approximately 107 Newton. Part C, normal force again is 12.7 12.7 kilogram times acceleration in y-axis, which is 4.78 meter per second squared, then plus the product of mass of the object and the gravitational force magnitude, which is 9.8. So if I put these numbers in the calculator, I end up with 12.7 times 9.8 plus 12.7 times 4.78 is approximately 185.2 Newton. For part D, the normal force is 12.7 kilogram, the mass of the object, times 9.8, which is the absolute value of the gravitational force, minus 145 Newton. Times sine of, the angle is above the horizontal, so it's positive 30.8 degree. If I plug in the numbers in the calculator, I can say that, let's see, 12.7 times 9.8 minus 145 times sine of 30.8 is going to be 50 Newton. Let's double check. Okay. Yes. So just pay attention if it was telling that it's under the horizontal, I would have changed the sign of this 30.8 degree to negative. So pay attention to those words, upward and above, or downward and under. Okay? Thank you for watching.